It is generally not recommended to swap an N5/20 plug for an N5/15 plug on a UPS, even if the AC input rating is 120 volts at 16 amps. There are several important factors to consider. Firstly, circuit protection is paramount. While the AC supply circuit may be protected by a 15 amp breaker, the UPS itself has an internal circuit designed to protect its components, including the transformer and the battery. If the load in the UPS exceeds 15 amps, this internal circuit may trip, potentially interrupting power to connected devices. Secondly, there is an overloading risk. The N5/20 plug is specifically designed to handle currents up to 20 amps. By using an N5/15 plug, you are limiting the current flow to a maximum of 15 amps. If the UPS attempts to draw more than 15 amps, the N5/15 plug could overheat, which creates a potential fire hazard. Thirdly, modifying the power cord by changing the plug could void the warranty of the UPS. It is strongly recommended to use the N5/20 plug that the UPS originally came with. This ensures that the UPS is properly protected and can safely handle the maximum current draw as specified in its documentation. As an alternative solution, if you need to connect the UPS to a circuit with only N5/15 receptacles, consider using an appropriate adapter instead of modifying the UPS power cord. Adapters that convert N5/20 plugs to N5/15 receptacles are readily available. It is important to ensure that the adapter is rated for the maximum current draw of the UPS to maintain safety and prevent overheating. The 16 amp input rating of the UPS suggests that under maximum load, it could potentially draw more than 15 amps. This is why the N5/20 plug is used. The N5/20 configuration provides a higher current carrying capacity, and using a smaller N5/15 plug could create a bottleneck. The internal components of the UPS are designed to operate with a certain current flow, and limiting that current with a smaller plug could cause stress on those components. The breaker in your panel will protect the wiring in the wall from overload, but it won't protect the UPS itself. The UPS has its own internal protection mechanisms designed to safeguard its components. By using the correct plug, you ensure that those internal protection mechanisms can function as intended. When selecting an adapter, make sure it is a high-quality adapter that is UL listed or has similar safety certifications. This indicates that it has been tested to meet certain safety standards. Cheap, uncertified adapters may not be able to handle the current safely and could pose a fire hazard. Also, consider the length of the adapter. A shorter adapter is generally better, as it reduces the risk of strain on the receptacle. Do not use extension cords with the adapter, as this can further increase the risk of overload. It is also wise to examine the N5/15 receptacle to which you plan to connect the adapter. Make sure it is in good condition and shows no signs of damage or wear. A loose or damaged receptacle can cause overheating and arcing. If you are unsure about the condition of the receptacle, it is best to have it inspected by a qualified electrician. Also, before connecting the UPS to any receptacle, verify that the circuit is properly grounded. A lack of grounding can create a shock hazard. You can use a simple circuit tester to check for proper grounding. If the circuit is not properly grounded, do not use it until it has been corrected by an electrician. Keep in mind that even with an adapter, you are still limited by the capacity of the 15 amp circuit. If you are running other high-power devices on the same circuit, you may still trip the breaker if the total current draw exceeds 15 amps. It is important to be aware of the total load in the circuit and avoid overloading it. If you find that you are frequently tripping the breaker, you may need to move some of the devices to a different circuit or have an additional circuit installed. In general, it is best to avoid using a UPS on a heavily loaded circuit. Ideally, it should be on a dedicated circuit with sufficient capacity to handle the UPS and any connected devices without exceeding the breaker rating. This will help to ensure reliable operation and prevent unexpected power interruptions. It is worth considering the potential consequences of a power interruption. If the UPS is powering critical equipment, such as a server or medical device, a sudden loss of power could have serious consequences. In such cases, it is especially important to ensure that the UPS is properly connected and protected. If you are unsure about any aspect of the installation or operation of the UPS, it is always best to consult with a qualified electrician. They can assess your specific situation and provide guidance on the best way to connect the UPS safely and effectively. Remember that electrical work can be dangerous if not done properly. It is always better to be safe than sorry when dealing with electricity. Working with electricity requires knowledge, skill, and adherence to safety precautions. If you lack any of these, it is best to leave the work to a professional. When working with electrical equipment, always disconnect the power before making any connections or modifications. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of your surroundings and avoid contact with any conductive surfaces. If you are working in a damp or wet environment, take extra precautions to prevent electric shock. Never work alone, and always have someone nearby who can assist you in case of an emergency. Before starting any electrical work, review the relevant electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and protect people from harm. It is important to be familiar with these codes and follow them carefully. In addition to the above considerations, it is also important to think about the long-term reliability of the UPS. A UPS is a complex device with many components that can fail over time. Regular maintenance is essential to ensure that the UPS continues to operate reliably. This includes checking the battery regularly and replacing it as needed. The battery is the most common point of failure in the UPS, and a failing battery can reduce the runtime of the UPS and potentially damage the connected equipment. It is also important to keep the UPS clean and free of dust and debris. Dust can accumulate inside the UPS and cause overheating and other problems. Use a vacuum cleaner to remove dust from the vents and other openings in the UPS. Avoid using compressed air, as this can blow dust into sensitive components. In addition to the physical maintenance of the UPS, it is also important to monitor its performance. Many UPS systems have built-in monitoring capabilities that can alert you to potential problems. Use these monitoring tools to keep track of the UPS voltage, current, and battery status. If you notice any unusual readings, investigate the cause and take corrective action. Finally, it is important to have a plan in place for dealing with a UPS failure. If the UPS fails, you need to be able to quickly restore power to the connected equipment. This may involve switching to a backup power source or replacing the UPS altogether. It is a good idea to keep a spare UPS on hand so that you can quickly replace a failed unit. Alternatively, you can arrange for a service contract with a UPS vendor that will provide rapid response and repair services. By following these recommendations, you can help to ensure that your UPS operates safely and reliably and protects your valuable equipment from power interruptions. Remember that electrical safety is paramount, and it is always best to consult with a qualified electrician if you have any doubts or concerns.